Welcome to the IOLink ecosystem. Energize your next automation project with smart devices. I'm Will Healy, Industry Strategy Manager for the Americas. With close to 300 member companies in the IOLink consortium, you now have access to over 13,000 smart devices and masters. From actuators to sensors, this ecosystem will empower your next automation project. We will review available technologies on the market that are proven to work with our market-leading IOLink master and complement the broad portfolio of IOLink devices available from Balluff today. So what I want to go over today is the IOLink architecture. I want to talk about different masters from Balluff because IOLink masters are the heart of the whole architecture. I want to then talk about automation output devices, start here on the left side of our wall, and work our way across the wall through control and I/O devices, and then finish with smart sensors. What's great about this is really the ecosystem at work. There are 14 different manufacturers represented here of the 300 that I mentioned earlier. I'd have to have a really big wall to be able to have all 300 of them on a wall, but this at least gives you a small representative sample of some of the devices that are out there and available that are complementary to what you already know from Balluff. Starting with the IOLink architecture. How is IOLink laid out? It's in a very similar layout to USB. In USB, you have a master device and you have the USB device. And the USB device is point-to-point communicating with the master. And similarly, we have that here in IOLink. You could see a master device, and each of these ports is connected to one IOLink device. And so you have the master to the IOLink device, and that allows us to communicate very similar to USB. It's a very simple plug-and-play architecture, and if you want to think about like a star topology or a spider's legs or something like that, that's a good way to think of it. But it's like USB in that you can only have one device plugged into one port. The other thing we have to talk about is with masters, there's two types of ports in an IOLink master that can be available from an IOLink master. The first type of port is called an A port. This uses 3 pins primarily. The pin 1 is the power, pin 3 is the common, just like a traditional sensor, and then pin 4 is utilized for the IOLink communication. So in an A-style port, this is good for input devices like smart sensors or devices that are just monitoring information. So you'll see A ports utilized for those types of devices. It's important to know the type of port and the type of device that you're plugging in because a B port allows you to control the output power. So it uses pin 5 as a second ground and pin 2 as an output power. So those are isolated from the IOLink communication and the IOLink device power. And that's nice because we want to be able to safely control the outputs like devices here on the left side of our demo. So A ports use 3 wires and B ports use 5 wires, and those 5 wires give you output control. So when we look at masters from Balluff, we have a wide variety of masters with lots of different protocols. We offer them with mostly as IP67 machine mount I/O blocks. So that means mount right on the machine outside of the controls cabinet, and we make them as network devices. So we have versions that are DeviceNet, Ethernet IP, Profibus, Profinet, CC-Link, CC-Link IE, and EtherCAT, as well as some other varieties. So these masters are machine mount I/O blocks, and we have them in a lot of different varieties as well. This one here is an 8-port version. We usually talk about the number of ports because that helps you understand how many IOLink devices you can hook in. So this is an 8-port version where the top 4 ports are A ports and the bottom 4 ports are B ports. That way you can have a combination of inputs and output style devices all in one master block. In the next master you can see here, we actually have, this is only A ports in a master, and we call these our slim. But the slim masters, they have 4 ports of A or 4 ports of B. So you can see this is 4 ports of B. So if you only need a few IOLink devices, that works pretty well. What's nice about a B port is if you have a simple A device with 3 wires, you can actually hook an A device into a B port. But you cannot hook a B device into an A port. So that's something good to know. So these blocks are either A ports or B ports as slim with four ports. That's a lot of ports. And then here's 8 ports. This is an 8-port A master. This allows you to hook a lot of A devices together. This is the type of master that we've had available the longest. We also have an 8-port A master available in the welding housing. The welding housing is a Fortron material, which is more resistant to weld spatter, which is a nice technology. And then last but not least, we have the IP69K washdown rated IOLink master, and this is an 8A port master that allows you to connect washdown devices in a food and beverage market type application. So lots of different masters to choose from that allow you to connect in lots of different applications and markets. Now what we're going to do is we're going to move on to the different types of devices that you can hook to masters. So we're going to start with automation output devices. So I have a small representative sample of those, but the first that I'm going to talk about are pneumatic devices. And there are a lot of really cool pneumatic devices out there, and IOLink provides some really great value for that. So the first is, you see here, we have two different types of vacuum. I have a vacuum pump and a vacuum generator here, one from Schmalz and one from Piab. And these two IOLink devices not only are vacuum generators or vacuum pumps, but they actually are providing diagnostic information and allowing you to control the vacuum pressure and these kinds of things, all with the device and over IOLink. So they have parameters as well as process data, and you can control the vacuum pump and get diagnostics from the vacuum generator right over the IOLink communication. And what's nice is with a master, like the master from Balluff, you can actually suck the parameters and the settings out of this device. You can store them in the master, so if this device gets damaged or fails, you can actually swap it out and the master automatically tells it what its previous configuration was, which is really slick. Next, you can see here pneumatic valve manifolds. So these are very common in automation, right? And what's cool about this is instead of having like a 25-pin D-sub with all the wires and output cards and short circuit protection you got to put in there, this is one sensor cable. It's a 5-wire cable because it's got to be that B-port style to control the output power for the valves. But from Festo here, you can see a B-port valve manifold that actually allows us to have control over all of that. It also gives you diagnostic information over the status of the valves, as well as any kind of diagnostics you want from the valve manifold. So this allows you to connect an IOLink device back to the master. Next, you can see from Parker, they also have a IOLink valve manifold. This one actually has remote power, so you can have it controlled by an A-style port with the power controlled as a secondary connector. So this is an A-style device that's also a valve manifold because they have the output power as a separate connection. And then down here at Ventix, which is no longer a Ventix, but their valve manifold here is also an IOLink device. It's a B-style port and allows you to mix valve sizes right there and control them and get diagnostics as well right over the IOLink connection. What's nice about all of these is there's no Ethernet connection. The power comes right over the IOLink connection, and it's just a simple sensor cable, 5-pole sensor cable to do that. So that's a very nice connection there. Next, we have electric grippers. So for automation output devices, we have electric grippers. So here's an electric gripper from the Zimmer group. This is really slick because you can actually control the speed that it opens and closes. You can control how far it opens and closes, and you get diagnostic status out of the IOLink device as well. And it has a very basic 5-pole connector, just like a sensor cable M12. This is a Schmalz electric needle gripper. Really slick because the electric needles, you can control how far out they come, how fast they come out, and have more control over what's going on with that electric needle gripper. And we do that all over the IOLink communication. And again, you get diagnostics out of that device. And then down here you can see the Schunk, the universal gripper from Schunk. It has the same capabilities as the Schmalz or the Zimmer grippers to be able to open and close and give electronic control over the device. So you can see here with automation output devices that we're using every day, like grippers and pneumatic valve manifolds and vacuum generators, there's a lot of possibilities that IOLink can bring to your application and bring more diagnostics to your application. Shashir is giving a great presentation on the value of IOLink for the smart factory, and with all of these devices, he's going to talk about how IOLink brings that value, and you're going to get additional value if you implement these kinds of IOLink devices as well. So moving on, I'm going to talk about control and I/O devices. So with control and I/O devices, there's lots of different possibilities, but I think there's some really slick ones. Of course, the Balluff Smart Light visual indication device is really interesting. You can actually have control over each of the individual segments of the light. It comes in 5 position with buzzer, 3 position, and then this what we call single position, but there's actually 4 segments there. So there's lots of variability, and you control it all over IOLink. Then here from ATI, they integrate a pinless connector system. So the non-contact connector from Balluff is integrated with an ATI coupler here. And the robotic coupler from ATI uses IOLink for the end effector. So maybe you want to have a valve manifold and an IO block out on the end effector of the robot. And you can send that with pinless connection using inductive coupling and a partnership with ATI Industrial Automation. Next, we have a Siemens motor contactor. I've had many customers talk to me about how much cost savings they got from this because of the IOLink control. They have ability to see how many switch points, and they have control over lots of the settings of the motor contactor, and they can actually stack motor contactors here, all controlled with one IOLink port. So that's a huge value for someone who's building an electrical cabinet, and there are manufacturers in the consortium, in the ecosystem, that make IP20 rack mount IO masters. So if you want to have that inside the control, you can actually have IP20 masters or an IP67 master to set up that architecture. Then we have discrete I/O devices like these from Balluff. There's a wide range and array of those devices. They take basic sensor information, not smart sensors, but on-off sensor information. They collect it together and then send it over a sensor cable. I really love this device. This is an analog input. So typically you have to have, an analog slice in your PLC, and you have to have grounding in the cabinet and make sure your shielded cable is protected in the cabinet. This actually collects the analog signals right out on the machine, does the analog to digital conversion on the machine, and then sends it over an IOLink connection. What's cool about this is you could tell each port to be something different. So one can be 4 to 20 milliamps, one can be a temperature value. You get to pick and choose what you want for each of these ports, and that has a high value if you have a lot of analog signals on your machine. And what's cool is the analog to digital is done here and then sent over the IOLink communication, so you don't have to worry about any noise or shielding issues inside a controls cabinet. Next, we have a low voltage switchgear from Phoenix Contact. So you can see here another opportunity for us to be able to control motors and conveyors and those kinds of things by using a contactor here controlled over IOLink with diagnostics over IOLink. And then industrial RFID. RFID is a great control device, whether you're doing work in process applications, traceability applications, tool identification applications, asset management applications, whatever you're trying to do with RFID, some of the best applications are integrated with IOLink RFID readers and integrated into an application with the master. I always like to talk about islands of automation, right? So in a work area, you might have one place where there's a lot of different automation pieces, and that's where this ecosystem comes into huge benefit for you, because you can get some control devices, you can get some output and automation output devices, and you can have those all come together at one master and have one IP address for that island of automation that you're running. So, last but not least, I'm going to move on to smart sensors. With smart sensors, there are a large variety of smart sensors, from photoelectrics to flow switches and all kinds of things like that. I'm going to focus on just a couple here. The SMC flow switch is an example. So this is a flow switch that has an IOLink communication. This one has an M8 connection, which is possible for IOLink. And the flow switch actually provides diagnostic data as well as the switching data for the flow switch. This is a HIDAC temperature sensor over IOLink, same deal. You can get set points out of it or a measurement value out of it, and you can get diagnostics out of the functionality of the device. Last but not least, we have the SMC Variable Regulator. The SMC Variable Regulator is really slick because with a variable regulator, one of the things that's always a pain is you have to have 2 analog signals. You have to have an analog signal for the output, what is the flow, and then you have to have an analog signal for the control. And so you have an input and an output analog, and that can be quite challenging. So with a variable regulator over IOLink, you can do all of that connection over a standard sensor cable instead of 2 analog channels, an input and an output, to make that happen. The Anderson-Hauser temperature flow sensor here, you can see it's actually giving you diagnostic data, empty pipe. Well, of course it's an empty pipe, it's just on my wall here. But it's giving us diagnostics, and it's actually reporting that diagnostic back to the master and saying, hey, here's what's going on with the temperature and the flow in the pipe. And then the Balluff pressure sensor here, we have a transducer without display and then a Balluff pressure sensor with display. And these provide pressure value. They have set points, hysteresis control. There's tons of values inside there, over 16 parameters that you can set and program there to set the pressure sensor. And again, what's amazing about IOLink is I can have all those settings from that sensor. I can have those downloaded and stored in the master. So if something happens to that pressure sensor, it gets damaged or needs to be replaced, when I swap that out, I can automatically send the last set of parameters to the device. So I don't have to sit there and set 16 settings with a 2-button push button, which can be frustrating. So when we look at the whole collection of IOLink devices, there's a lot of really great opportunities here to broaden our automation applications, to really bring everything together. And the IOLink ecosystem is really enabling you to be able to energize your next automation project with smart devices.